Remember, as I'm saying, hypothesis testing is a statistical method used to make decisions or inferences about a population based on sample data. And I am saying that sometimes you have a big chunk of data. Maybe let me say you have, let me take an example of 1,000 maybe data values. But you might also go ahead and just pick a sample of maybe 100 or 50. You may pick 50 data values to represent this 1,000. Then, when you analyze this 50, then you can make decisions over the whole sample. I mean, over the whole population. So what am I trying to say? Hypothesis testing will help you to make decisions or inferences or make some senses or make some deductions on what is happening with this sample to represent the impact, of course, that would be on the whole population. So someone can ask you that, for example, you are given data of the number of hours students spent on TV versus their scores in a particular paper. Okay, maybe they were subjected to a number of hours before they did a particular test. So you'll find that maybe a student who spent 30 minutes on a TV scored highly. Another one who spent a lot of time on TV scored badly. But then you go ahead and maybe do what we call you carry out the statistical analysis, but trying to ascertain the association between the two. Maybe you use the pmcc, product moment correction coefficient. So once you get this, it informs you of the association between the two. But someone can go ahead and ask you, you use the sample 50, but is there sufficient evidence to show that actually there is a positive correlation between the number of hours a student watched versus their scores in the test that was administered the next day? So to, for example, answer that person, one needs to carry out a hypothesis testing. So steps that are always involved: one, we need to state the hypothesis. If it is involving the PMCC or the product moment correction coefficient, in most cases, the null hypothesis involves your statement as regards to rho. What is the value of rho? And the null hypothesis always takes rho is equal to 0. Then, depending on the type of test that you're going to do, the alternative hypothesis, others use HA. Okay, so if you find HA, H subscript 1, then they are meaning the alternative hypothesis. So that alternative hypothesis, here the rho is equal to 0 means that there is no correlation, or there is no correlation, or there is no relationship between the two. Okay, then this alternative hypothesis, then rho is not equal to 0, and therefore there is a relationship between the two. Then you go ahead. So there are a number of parameters that you're going to use to be able to prove these statements. And one of them that we said we can use is a t-test. Okay, you carry out a t-test and get critical values at a significance level of 0.05 or 5%. When you get that critical value is compared with the value that you calculated as the test statistic. Depending on the type of the sample, the population you're dealing with, we are going to look at the conditions. Then you are able to get your t value. You're going to get the test statistic. Then you compare it against the critical value. So if you'll find that the value that you have obtained is within the rejection region, then you can reject the null hypothesis. If it is not, like it is outside the rejection region, then you fail to reject the null hypothesis, and then of course that means there won't be sufficient evidence that that claim actually exists. Then alternative hypothesis. This is what you want to prove. It suggests that there is an effect or difference. For example, there's a difference in mini test scores between the two groups. We shall look at examples. Then the next step is to choose the significance level. Like I said, that significance level given values we say the significance level is the probability of rejecting the null hypothesis when it is actually true. So the common values are 0.05, 0.1. This is the 5%. This is the 1%. And this is the 10%. Okay, 10% significance level. Then select the appropriate test. Depending on the data and the research question, like I told you, you can use a t-test, a z-test, a chi-square test, ANOVA, etc., etc., as we shall see. Then the other one is that you need to calculate the test statistic. The statistic is a standardized value that is calculated from sample data during a hypothesis test. Examples could include the t statistic for a t-test or z statistic for a z-test. Determine the p-value. The p-value is the probability of observing the test results at least as extreme as the results actually observed under the assumption that the null hypothesis is true. Okay, we shall see where you can use the p-value and also be able to make a decision. So from there, you make a decision. You reject the null hypothesis if the p-value is less than or equal to the significance level. P is less than or equal to alpha. That is, the value of alpha can be 0.05 or 0.01 or 0.1, depending on the significance level. Reject the null hypothesis if we have the p-value less than that. This suggests that the observed data is inconsistent with H naught, so indicating that H1 may be true. Then another one is that you can fail to reject H naught if the p-value is greater than the significance level. For example, p is greater than the alpha. Maybe you've gotten the p-value which is greater than 0.05. Then you cannot reject the null hypothesis. And it suggests that there is not enough evidence to support the alternative hypothesis. Then you draw the conclusion by saying, based on the decision to reject or fail to reject the null hypothesis, you can make an inference. Like you can say there is no sufficient evidence to support the claim. The key concepts, these ones we shall not do much on them, but what I wanted us to understand is when we have a one-tailed test and a two-tailed test. A one-tailed test tests for the possibility of relationship in one direction, greater than or less than. A two-tailed tests for possibility of the relationship in both directions. Okay, now I'm going to show you if we are talking about doing a test on correlation. So first of all, on correlation, that means we are talking about we need to determine the product moment, correlation coefficient.